Alkanes are saturated hydrocarbons. They are called hydrocarbons because they are made up of carbons and hydrogens. The bonds between them are only sigma bonds. Whenever you want to represent an alkane, you represent it as a long carbon chain. Now, the length of the chain depends on the alkane itself. You can have starting from one carbon until X number of carbons in there. But normally when the chain is a straight chain like this one, this is called a straight chain. Straight doesn't mean that the carbons lie in a 180 degrees. Straight chain means that the chain is not branched. Then in this case, we name the chain as an N-R chain. Now, notice whenever we want to represent an alkane, we have a bond angle that we need to take into consideration because every one of these carbons is an sp3 hybridization. So every one of these carbons need to have two bonds in plane, one bond in front, and the other one behind. So this is how we represent it and on paper in a 3D model here. So two bonds in plane, one bond in front, and the other one is behind. It's easier whenever you want to represent a tetrahedral carbon to have the bonds in plane to be the carbon chain. So for example, for this carbon over here, it's easy to show that the ones in plane are the ones that belong to the carbon, and then put the hydrogens one in front and the other one behind. This is an example of an unbranched alkane chain. It's a long chain which is made up of 11 carbons. Decane means 10, un means 1. So this is a chain of 11 carbons. And the molecular formula follows the CnH2n plus 2. If you are working with hydrocarbons other than alkanes, then you have to calculate the double bond equivalence. This is the formula of the double bond equivalence. You're going to add halogens to the number of hydrogens if halogens exist in your molecular formula, and if there is nitrogen in your molecular formula, subtract it from the number of hydrogens. Double bond is a DBE of 1, and the cycle is a DBE of 1. And then if you have a DBE of 2, there might be a combination between double bonds and cycles, or you will have a triple bond. Alkanes are nonpolar. If you take a look at the simplest alkane, which is methane, this is a tetrahedral geometry for the carbon with a bond angle between the hydrogens in plane to be 109.5. Because the carbon and the hydrogen, both they have very similar electronegativity, with carbons being slightly more electronegative than that of the hydrogen, the pull of electrons is going to be towards the carbon. So in this case, you're going to generate a dipole. Those two arrows are going to cancel out, and those two arrows are going to cancel out. So that is going to leave the methane to have a zero dipole moment, which is nonpolar. Making alkanes nonpolar, meaning that they are not water soluble. They are only soluble in organic solvents, no matter how many carbons they have. The only intermolecular forces they have is the van der Waals forces. Alkanes less than 5 carbons are gases, and more than 5 carbons are liquids. There are two methods that we're going to use to name alkane chains. One is the systematic method of naming large alkane chains. We call it IUPAC method, or the systematic name. And the other one is to name smaller alkanes, and this is the common method. To name alkanes, we're going to use this table in here, and the number of carbons that you would need to know how to name are from carbon 1 until carbon 20. Notice that when we are naming the alkane, we're going to start always with our parent name. The parent name is simply the name before the A and E. All alkanes, they end up in A and E at the end. And then whatever comes before the A and E, that represents how many carbons you have in your main chain, which is the longest carbon chain. So if you have one carbon, then it's going to be a meth. If you have two carbons, then it's going to be an F. Three carbons, prop. Four carbons, but, and so forth. Oct stands for 8 carbons. Non stands for 9 carbons. Dec 10 carbons, and then you add as you go. So un means one in addition to the decane, so it's going to be 11 carbons. Do means two in addition of the decane, it's going to be 12 carbons. And then you have the tri means a three, tetra means four, penta means five, all the way until the 20 carbons, which is icosane. So to name an alkane, so start from one end of the chain and go through the chain to reach the maximum number of carbons that you can get. So here I am getting a 9 carbon chain. No matter which way I go, I cannot get in this particular example more than 9 carbons. Now, the longest carbonate chain is not necessarily a straight chain in there. Here in this example, it is a straight chain. So I start from one end, and it doesn't matter which end you start, but when you start from one end, please continue until you get to the other end in here. So here I have a chain of 11 carbons in there. This is the maximum number of carbons that I could get here. Your chain does not have to be a straight one. It can be a curved one. Like for example, here, if I start from this carbon and go all the way, this is a 3, 4, 5, 6, 7, 8, 9, 10, and 11. See, this is my chain in here. So I can start this way. This is 1 and this is 11 carbons. I can also start like that. I can start from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this is another example that your chain does not have to be a straight chain to pull out the maximum number of carbons. It can be a bent chain, it's fine. But there is a rule. If you start from one end, you have to continue all the way until you reach the next end. Once I choose my longest alkane chain, then I have to name that alkane chain and put the name at the end. This will be my parent name. So this is a chain of 11 carbons. It's going to be an undec. This is going to be my parent name. And what comes next is going to decide what type of organic compound I have. In other words, functional group. But alkanes here are not functional groups. So here my ending is going to be an A and E at the end. Next, I want to go ahead and circle the carbons that are coming off the main chain. These carbons, I'm going to call them substituents. To name those substituents, I cannot name them like the regular alkane chain because my ending of the regular alkane chain always ends in A and E. This is specifically for the parent name in there. So we're going to go ahead and drop the A and E for the substituent. So instead of methane, it's going to be a methyl. We're going to add a YL in there. And then start numbering from one of the sides that gives the first substituent the lowest number. So here I need to start numbering from the side to give this substituent, because it's closer to this end, the lowest number. So my numbering here is going to be carbon 1, carbon 2. So this CH3 now is going to be on the second carbon, on carbon number 2. This is a 3. This is 4, 5, 6, 7, 8, and 9. So to name this alkane, see how many substituents I have. I have on the second carbon a CH3 in methyl. I have similar methyls on carbons number 3, number 4, and number 7. On 3, I have 2 methyls in there. every substituent needs to have a number. So I open the parentheses and put all of these numbers for these methyls. So the methyl here is going to be on 2, 2 threes, on 4, and on 7. I close the parentheses. I put normally commas between the numbers and dash between the letter and the number. That's going to be dash. And then since all of these are CH3s and I have 5 of them, then it's going to be penta. It's going to be a methyl, not a methane. A-N-E is always reserved until the end. It's going to be pentamethyl, and then the ending is going to be the nonane. Whatever comes before the parent name is the substituents. And again, every substituent needs to have a location. The location is represented by a number. So if you miss a number, this means that your naming is going to be wrong. If you have two substituents that are the same and they are located at the same ends of the carbon chain. So for example, if I start numbering from here, this methyl is on the second carbon. If I start numbering from this side, this methyl is also on the second carbon. So it doesn't matter which end you start numbering at, as long as there is no other substituent in here. If there is another substituent in there, then you have to look at that substituent and give it the lowest number. So let's name this one here. I'm going to go ahead and start numbering from the side. So that is going to be 2, and there's going to be on carbon number 10. So the name is going to be, put the numbers first, 2, 10. Now, it's a choice to either put them in or parentheses, not brackets, parentheses in there, if there is more than one number, or you can take the parentheses out. So it's really up to you, but make sure between the numbers there's a comma, between the number and the letter there's a dash. So it's going to be 210. I have two methyls in there. It's going to be a dimethyl. There is no space between the undecane and the dimethyl, so just make sure to put them very close to each other in there. Don't show any spaces. Okay. On the other end, let's say, for example, if I have something like this, here you go. If I have a methyl here and a methyl there, and then I have another CH3 in here, okay? So in this case, I choose my longest carbon chain. Here you go. And circle the substituents. I have 3 substituents in here. So if I start numbering from this end, this methyl is going to be on carbon number 2. And if I start numbering from the other end, this methyl here is going to be on carbon number 2 as well. So in this case, I need to look at the second substituent. The second substituent is close to this end, so this one needs to get the lowest number. So I have to start numbering from the right. This is going to be 1, 2. This is going to be 3, 4, 5, and 6. It's a chain of 7 carbons in there. So 7 carbons, the name is going to be a heptane. So this is the first thing that you do. Name your parent chain first, put it at the end, then number or name the substituents. Here, all of these are CH3s. I'm going to give each one a number. So it's going to be 2, 3, and 6. And notice the numbers need to be from the lowest number to the highest number, 2, 3, and 6. And it's going to be trimethyl and heptane. Now, let's say if my substituents are different, then in this case, I need to go by alphabetical order. So choose your longest carbon chain and then circle your substituents and name them. So here I have a substituent of 3 carbons. I'm going to name it propyl. Substituent of 3 carbons again. I'm going to name it propyl. And it is a 3 carbons. Count the carbons in there. This is carbon 1, carbon 2, carbon 3. Carbon 1, 2, and the 3 in there. And then I have my last substituent, which is a chlorine. Instead of naming it as a chlorine, I'm going to name it as a chloro. Normally, the halogens are named as halo, compounds whenever they are connected to the alkane chain. So you have chloro, bromo, fluoro, iodo, and so forth. So you have here two sides you can start your numbering with. I'm going to start with the side that is closest to my first substituent. So here I'm going to end up having my numbering to be carbon 1, 2, 3, 4, 5, 6, 8, 9, 10, and 11. So this is an 11 carbon chain, so it's going to be an undecane at the end. My substituents are different. Chlorine or chloro is different than propyl. So I need to go by alphabetical order now. Before I didn't care because all my substituents were the same, but here now they are not. So I need to go by alphabetical order. Chloro comes first before the P. C comes before the P. So I am gonna start by every substituent, giving every substituent a number. So the chloro is on the second carbon. So it's going to be 2 chloro in there. The dashes are part of the name and they are important. And then I have 2 propyls on carbons 6 and 7. Start with the lowest number and then the highest number in there. So 6, 7, and then a dash, and it's going to be a dipropyl. There is no space between the propyl and the undecane, so go ahead and put them together. Okay. Let's have another example here. This is the example where you have the substituents are the same on both sides of the chain. So you look for the second substituent and give it the lowest number. So here, all of whatever I'm circling is the substituent. So these are the substituents coming off the main chain. So if you start numbering from this end over here, the CH3 is going to be on the second carbon. If you start numbering from this end, the CH3 is going to be on the second carbon. Those two are the same. So this is why you need to go this way so that to give the second substituent the lowest number. So my numbering has to start from this carbon, and I'm going to end up having 1, 2, 3, 4, 5, 6, 7, 9, and 11. Okay, so the ending of my name is going to be an undecane again. So that is going to be an undecane. Now, let's go ahead and group these substituents. I have two different types of substituents. I have my methyl substituents, and the methyl substituents are these substituents here. All of those are my methyl substituents. This is another methyl substituent. And then I have a substituent of 2 carbons, which is the ethyl substituent. So there is a difference between the M and the E. So now I have to arrange them in alphabetical order. E comes first. So you start your naming with 7, ethyl. Again, the number is the location. So if you miss the number, then we don't know where the ethyl is on the chain. The chain is 11 carbons. It can be anywhere. So the number is important. So it's going to be 7 ethyl dash. And see how many methyls I have? I have 4 of them. So go ahead and list them from the lowest number to the highest number. So this is going to be 2, 3, 4, and 10. I have 4 of them. So this is going to be a tetra, methyl, and then the undecane. Another example, you have a bromine, you have a chlorine in there, and both are on the same ends of the same chain. So choose your longest carbon chain, which is 5 carbons in there, and then start numbering to give now the first alphabetical order the lowest number. So B comes first in the bromo, so this is why you have to start numbering from this side. Common names are used to name small alkane chains. Normally, those small alkane chains are branched chain. For example, If you have a branch coming off the main chain and that branch is made up of a CH and two CH3s, then I'm going to call it an iso. Since it's a three carbons, we call it propyl. So iso has this shape. So iso means this shape. Those you need to memorize. So iso has this shape, and then you count the number of carbons in there, the total number of carbons. It's three carbons. This is why I call it propyl. If I add a carbon, so let's say I have the iso shape in there, and I add an additional carbon, which is this carbon over here, then this is going to be iso, but the total number of carbons now is going to be butyl. So it's going to be an isobutyl group. Another branched hydrocarbon that we name as a common is a tertiary butyl group. The tertiary butyl group is a carbon that is connected to three carbons. So you have four total number of carbons in there. This is why you have a butyl. Tertiary because this carbon over here is a tertiary carbon because it is connected to three carbons in there. So this is coming off the main chain. This group is coming off the main chain. So whenever you see it, you can name it as a whole. And this is an easier way of naming these branches. So it's going to be called tertiary butyl group. Please put a dash between the tertiary and the butyl. Another group that you are responsible to name is the secondary. This is a butyl group, and the connection of the butyl group to the main chain is of its second carbon. Iso is part of the name. So whenever you want to alphabetize, you look at the I and not the P. On the other end, tertiary and secondary are not part of the name because when we write them, we write a dash between the T or the sec and the actual name. So when you want to alphabetize, you look at whatever comes next. Here I'm looking at the B, so you alphabetize the B and not the T. Here you alphabetize the B and not the S in the secondary. Cyclo, we're going to talk about it as we proceed. Cyclo is considered to be part of the name, so you alphabetize the C. Let's have an example. If you have a case where you go with multiple paths and all result with the same number of carbons. Here I have a structure drawn 4 times just to show you those 4 paths in there. I do have options here. So I can start either from this end, or I can start from this end here, or I can start from this end, or I can start from this end. So let's see how many carbons are we going to get. And we're going to pick the route that gives me the highest number of carbons. So if I start from here, that is going to be 3, 4, 9 carbons. So I'm going to end up having 9 carbons this way, going this way. If I start from here, then this is going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Still 9 carbons in here. If I go this way, then it's going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have again 9 carbons this way. And if I start from here, that is going to be 1, 2, 3, 4, 7, 8, and 9. See how many routes in there that give me the same number of carbons? So which one do I choose? The rule says that you have to choose a route that gives you the most number of substituents. Okay, and it's preferred that the substituents are not bulky. So let's go ahead and circle the substituents. So if I go with the first one I have 2 substituents, and these are bulky. Okay, the second one I have 1 substituent here. I have a methyl, I have a propyl, and I have an isobutyl. So here I'm ending up having 3 substituents. Here I'm ending up having 2 substituents. Here I'm ending up having 1, 2, 3, and 4 substituents. So far this is the winner. Okay, and in this route I'm going to end up having a bulky substituent here. this substituent, and so this is going to be three substituents. So out of the three choices in there, I'm going to pick this route in there that gives me the highest number of substituents. So in order to name this now, here I'm going to start by numbering the chain that is closest to my first substituent. So the ending is going to be no name. And then this is a propyl, this is ethyl, and you have the two methyls on carbons 2 and 7. So I'm going to start with the ethyl on carbon number 3. And then I have on 2 and 7, I have a dimethyl. And then on 6, I have a propyl, and then nonane. Let's have another example. With this example, again, you choose the longest carbon chain. So here, my longest carbon chain, no matter what route I go with, the longest carbon chain that I can pull out here is 15 carbons. Then I have the choice of either starting from this end to number or starting from the other end to number. If I start from this end on carbon number 5 here, I would end up having two groups, two substituents on carbon number 5, versus if I start numbering from this end there, then on carbon number 5, I'm going to end up having this one bulky substituent. So this is why I need to start from this end over here in numbering. So that is going to be 1, 2, this is 6, 9, 10, and 11, and all the way to 15. Now to put the substituents in there, let's highlight the substituents. So I have this tertiary butyl group, I have the isobutyl group, I have the secondary butyl group. So these you would need to know, okay? And the ethyl group, and then the two methyl groups in there. So I have 6 substituents. List them like this first, because you're not used to naming. After you do a lot of examples, you can skip this step. But for now, just list them like that. And now we need to arrange them in alphabetical order. With the prefixes di, tri, tetra, you ignore. So you do not alphabetize the D and the di. You look at the M and alphabetize the M. So the ones that we need to alphabetize here, I'm just going to highlight them. So we need to alphabetize the M, the B, the E, the I, and the B. We skip the tertiary, we skip the secondary, and we skip the D and the di. B comes first, and because both of those are a tie, we're going to list both of them, but the one that has the lowest number is the one that is going to go first. So this is going to be 6 tertiary butyl, 11 sec butyl in there, so we're done from those. Then the E is going to come after the E. We're going to have the I in the iso, and then we're going to have the 5,5-dimethyl. Please don't forget the prefix di. Here you have two CH3s. Each one gets a number, and then the rest of the name, which is a pentadecane. A complex substituent is a chain of carbons that is coming off the main chain. Now, we've seen some complex substituents in there, like the secondary butyl, the tertiary butyl, and the isopropyl. Those, we've seen how to name them with common naming. There's also another way, which is the IUPAC name that I'm going to explain. In the exam, I'll be very specific if I want you to use the secondary, the tertiary, the iso, or if I want you to name them using the IUPAC name. So let's go ahead and have an example in here. The first thing that you do is you choose your longest carbon chain. So this is going to be here my longest carbon chain, and start numbering from the end that gives the first substituent the lowest number. So if I start numbering from here, it's going to be 1, 2, 3, 4, and 5. Here is going to be 1, 2, 3, 4, 5, and 6. So definitely we're going to start from the other end. Okay, this is a chain of 13 carbons. So this is 5, this is 6, 7, 8, and 13 in there. So the ending is going to be tridecane. Put the ending at the end. And now for the substituents. The substituents that we have are the secondary butyl. This is the common way to name it. And the tertiary butyl. So this one is the tertiary butyl. And this one is the secondary butyl. So in case I ask you, go ahead and name it, and I have no problem for you using the secondary and the tertiary in the IUPAC, then here you go. So you're gonna start by alphabetizing in this case. B's are the same. You look at the U's are the same, the T's are the same, so everything here is the same. So you're gonna give the second butyl the lowest number, which is gonna be 5. So the name as a common is going to be 5-sec-butyl and 8-tertiary butyl and the tridecane. There is no space in there. This is in case I ask you to name it as common. Now, if I want to go ahead and name it as IUPAC. So in this case, we're going to go ahead and reach the first substituent in there. So we have on carbon number 5, put a dash and open the parentheses. Because on 5, I have this whole bulky group there. This is on carbon number 5. I have this whole thing. So this whole thing is connected on carbon number 5 through its carbon number 1. We're going to treat the secondary butyl here as if it's a chain on its own. So as we did to the main chain, choose the longest carbon chain, we're going to do exactly the same thing. So once you figure out your point of connection, in there, then from that point of connection, I have 2 directions to go, either to the right or to the left, right? So you choose the path that gives you the most carbon numbers, and it's this one over here. So if I go this way, I go by 1, 2, 3 carbons. If I go this way, then I go with 2 carbons. So here I'm going to end up having 3 carbons. So this is going to be carbon 2 and carbon number 3. So that is going to be the main chain of this branch, ending up in 3 carbons, which is a propyl. After all, this is still a branch from the main chain, so I cannot end it with ANE. So that is going to be a propyl. And on carbon number 1 of the propyl, I have my methyl group in there. So that's going to be 1-methyl propyl. And I'm going to close the parentheses. I'm done from 5. Now for 8. So I'm just going to go ahead and open the 8 in there and do the same thing. So this is my connection, which is carbon number 1. And then these are the routes that I'm going to pick to get the most carbons. It's going to be either 1, 2, or 1, 2, or 1, 2. So no matter where I go, it's going to be a max of 2 carbons in the chain. So I'm just going to go this way. That is going to be a 1, 2. So it's going to be an ethyl. And on carbon number 1, I have 2 CH3s here, so it's going to be dimethyl. It's going to be 1, 1, dimethyl, ethyl, close, and then it's going to be tridecane. Let's have an example, and let's name it in 2 ways, in the common way and in the IUPAC way. So for the common, we're going to go ahead and choose the longest carbon chain. And this is the only route in there that's going to give me 10 carbons. And then we're going to start numbering from the end that gives the first substituent the lowest number, and that is going to be this end over here. It's going to be 3, 4, 5, 6, 7, 8, 9, and 10. And then let's highlight our substituents. We have the isopropyl. We have the secondary butyl over here on carbon number 5. We have the propyl group on carbon number 6. This is a 3-carbon chain. And don't forget the methyl. Let's go ahead and write them down. So on carbon number 2, we have the methyl. On carbon number 4, we have the isopropyl. And I'm writing them just to list them in alphabetical order. You can skip this step if you feel comfortable. Just list them right away. This is going to be 5 isobutyl. And then on 6, I do have a propyl. So the first one is the isobutyl. This is going to be my first alphabetical one because you need to look at the I in the iso. The I in the iso comes before because these two isos are tied. So the B comes before the P. So this is why I have my 5 isobutyl. Okay, dash. Don't forget the dash. And then I need to go with the isopropyl because iso comes first. Propyl. And then after that, I need to go with the M in the methyl. So this is 2-methyl. And then the last one is going to be 6-propyl. And it's going to be decane. Guys, pay attention that every substituent needs to have a number. This is the common name. Now for the IUPAC name, I'm not going to use the isos over here, so I'm just going to name it as a branch coming off the longer chain. Let's use another color here. Okay, so on carbon number 4, this is going to be carbon number 1, and this is carbon number 2 in there, and this is a substituent that is coming off that. So to name this guy, this is going to be on 4, open the parentheses, and I have 1-methyl ethyl. Okay, and then for this branch that is coming off, I'm just going to name this as carbon number 1. So this is going to be carbon number 1. And then I'm going to move along this chain to choose my longest carbonate chain in there. So this is going to be my longest carbonate chain. And on that longest carbonate chain, on the second carbon, I do have a methyl group, B-propyl. Okay. And then I have on 6, I have a propyl group, and this is going to be on 6. No need for me to put any numbers here because this is not a branch. And then, of course, I do have on 2 over here, I do have my methyl. Let's arrange in alphabetical order. So starting, all of those have methyls. This is a methyl, this is a methyl, and this is a methyl. So this one is going to be my highest priority since there's no other groups next to it. So this is going to be a 2-methyl in there. Okay. And then between the 4,1-methyl ethyl and the 2-methyl propyl, the E comes before the P. So that is going to be 4, open, 1-methyl ethyl, and then 5, 2-methyl propyl, and then 6 propyl, and then decane.